your new topic in the core course is going to be trigonometry. Okay, trigonometry, it's a branch of geometry, and the word trigonometry came from the Greek words trigonon, which means triangle, and metron, which means measure. So put them together, and basically you're studying the measurements of triangles. Okay, so specifically finding the lengths of sides that are missing, or the sizes of some angles. This can be used in a few different parts of the real world. So one is surveying. So these people use trigonometry to find the heights and the distances of certain things. Navigators would use it to calculate their bearings, so their positions and their distances. And I don't know much about astronomy, but I'm sure they would do something similar to the navigators, just on a much bigger scale. I might be wrong, ask Pink Sun, he knows more than me on this. Okay, so first we're going to look at how we can name sides. So it's a pretty simple thing, but it's just a few little bits of convention with triangles. So if you have a right angle triangle and you have one angle, so we have an angle here, theta, right? Basically, it's a Greek letter that they use. Comes up in pretty much every triangle when you're missing an angle. Don't know why, but they like to use theta. And we name them based on their positions from this angle. So first of all, in this triangle here, AC would be the hypotenuse. Right, you should know that by now. It's opposite the right angle. Hypotenuse is always in the same place. For the other two, this is where we look from that angle. So from the angle theta, if we look directly across or directly opposite, we will get the opposite side. Okay, so it's called opposite because it is straight across from the angle. And the third side, it is next to the angle. It's not the hypotenuse, but it's next to the angle, so it is adjacent. Okay, so they're the three names you need to know: opposite, adjacent, hypotenuse. So for each of these, name the three sides. So if you look at the first one, first, it's always easiest, name the hypotenuse. Okay, because that is always the same. After that, we look from the angle we've been given. Directly across from theta is YZ, so it is opposite. And last of all, the one we haven't used is XY. That will be adjacent. Okay, so you need to be able to identify these sides. Same in the next one, PR, it's opposite the right angle, it is the hypotenuse. Right, and then you start to get lazy, so you can shorten it to HYP. Then from the angle that you're given, theta directly across is PQ. It is the opposite. So you can shorten that to OPP. And the last one is QR. It is adjacent. And third triangle, again, start with the hypotenuse. It's always in that same spot, opposite the right angle. So AB. From the angle, you get BC is opposite that angle, and AC is adjacent to it. Okay, so there's three trigonometric ratios we're going to have a quick look at today, and they're all based on where these sides are in relation to an angle. So we have our three sides, so now there are three ratios. Okay, first one is sine. All right, it gets shortened to SIN, but it's not sin, it is sine. Okay, and the sine ratio is always equal to the opposite side over the hypotenuse. The next one is cosine or cos. Okay, cosine. All right, it's always the adjacent side over the hypotenuse. And the last one is tan, or that is short for tangent. And it's equal to the opposite over the adjacent. Okay, so we're looking at these ratios in the triangles. It helps us find missing sides and angles. We're going to do more of that later though. So first, find the trigonometric ratios. So that means work out what they all are. So first, we'll label the sides. So in this one here, 5 is the hypotenuse. Go straight across from theta. That's opposite. And the last one is adjacent. So we know sine theta is opposite over hypotenuse. Okay, so O over H for short. So 3 over 5. We know cos theta, cosine, is adjacent over hypotenuse. So 4 over 5. And tan theta is opposite over adjacent. In this case, that would be 3 over 4. Okay, we can do the same with the next one. We have the hypotenuse there still. Opposite theta is 63, so that's O there. A is the one left over. So sine theta will be equal to opposite over hypotenuse, which is 63 over 65. Cos theta is adjacent over hypotenuse. So the adjacent is 16 over 65. And tan theta is opposite over adjacent, which is 63 over 16. And last of all, again, hypotenuse, opposite, adjacent, sine theta is going to be 9 over 15, which is 3 over 5. Cos theta is adjacent over hypotenuse, 12 over 15, 4 over 5. And tan theta is 9 over 12, 3 over 4. Okay, and now, nice little thing to notice there. If you look at the first and the third ones, they had the exact same values for sine, cosine, and tan. All right, that's because they are similar triangles. Okay, so you'll see that the ratio of the triangles is the same for all the three sides. Also means the angles will be the same. Okay, so basically all of these ratios, they're kind of based on the rules of similarity as well. Again, we'll look at more of that later. So a few more things we can do. All right, so this time, find sine, cos, and tan of theta in this trapezium. All right, so first of all, we need to know what this is here. All right, we're dealing with right angle triangles, so that will be 9. All right, and this one here will be 46 minus 6, 40. So sine theta is opposite over hypotenuse, so that's the opposite, and the hypotenuse is there. Cos theta is adjacent over hypotenuse, so 40 over 41. And tan theta will be opposite over adjacent, 9 over 40. And the final idea we're going to look at today, if we know one of the trig ratios, we can find the others. So if sine theta is 5 over 13, find the other two. So whenever you see something like this, first you should do is draw a triangle. So draw a right angle triangle, okay, and one of our angles is theta. So this is telling me here that opposite over hypotenuse is equal to 5 over 13. So in my triangle, that's my opposite side, so I'll call that 5. My hypotenuse, 13. That means I have a right angle triangle. I can find the third side. So simple Pythagoras. Okay, so that's a triad, so it's nice and easy. X is 12. So after that, cos theta will be adjacent over hypotenuse, and tan theta is opposite over adjacent. Okay. In the next one, you have cos theta is 2 over 3. So again, this is cos, which is adjacent over hypotenuse. So draw a triangle, always drawing triangles. Put theta in some position. It doesn't matter which one you choose, you'll get the same answer in the end if you do it correctly. And we know adjacent is 2, hypotenuse is 3, and this one here will be square root of 3 squared minus 2 squared, so square root of 5. So the other two, sine theta is root 5 over 3, and tan theta would be root 5 over 2. Alright. Next we have tan theta equals 1.6. So to make this easier, this is opposite over adjacent. To make it a little bit easier, change it to a fraction. So 1.6 is 8 over 5. Now draw the triangle. Put theta somewhere. I'll put it up here just for a change. So the opposite side is 8. Hypotenuse, we don't know, but that side is 5. So this will be square root of, so that's 64 plus 25 is 89. So sine theta would be 8 over root 89, or if you really wanted to, you don't have to, but you could rationalize, and cos theta is 5 over root 89. And again, if you want to, you can rationalize. And last of all, cos theta equals 5 over 4. So there's two ways you could do this. You can do it the same as the other one. So I've got draw a triangle. Theta will go here. 5, 4. Find the missing side. So x squared plus 5 squared equals 4 squared. X squared plus 25 equals 16. Now your x squared equals minus 9, so there is no solution. Okay, the other way you could have done it, if you have cos theta equals 5 over 4, this is adjacent hypotenuse. Okay, remembering hypotenuse is the longest side. So hypotenuse is the longest side, so it must be greater than adjacent. Right? You can't have one side longer than the hypotenuse in a right angle triangle. That just breaks all the rules. So it is impossible. Okay, so cos theta will not be equal to 5 over 4. It's absolutely impossible. So obviously the other two don't have values either. Right, we'll do some more of this next week. Hope this all made sense to you. Have a good weekend, everyone.